This is AP problem number 1. The question is, water is added to 4.26 grams of UF6. The only products are 3.730 grams of a solid containing only uranium, oxygen, and fluorine, and 0.970 gram of gas. The gas is 95% fluorine and the remainder is hydrogen. From these data, determine the empirical formula of the gas. First, to find the empirical formula of the gas, you do turn the percents into 100 gram products, and you get 95.0 grams of fluorine and 5.0 grams of hydrogen. You put them over their molar mass, and you get 5 moles of each, which goes to HF. For question B, what fraction of fluorine and the original compound is in the solid, and what fraction of the gas after the reaction? Here's B. You start with 4.267 grams of UF6 times 1 mole of UF6 over its molar mass, which is 352 grams. Then you multiply by the molar ratio, which is 6 moles of fluorine to 1 mole of UF6, which gets you 0.07273 moles of F in the original. To find the other one, you have 0.970 grams of HF, which is the gas, times 1 mole of HF over 20.0 grams of HF, which is its molar mass. You multiply that then by the molar ratio, which is 1 to 1, which then you get 0.0485 moles of fluorine. Then, to find the percent composition, you do 0.0485 moles of fluorine over 0.07273 moles of fluorine times 100, which you get 66.68% F in gas. Then, to find it in solid, you subtract the 66.68 from 100, and you get 33.32% F in the solid, which is fluorine. For question C, it asks, what is the formula of the solid product? This one is pretty lengthy. You start with 4.267 grams of UF6 times 1 mole of UF6 over its molar mass, 352.0 grams, times the molar ratio, which is 1 to 1, and you get 0.01212 moles of uranium. Then you subtract 0.0723 or 0.07273 from 0.0485, which you had found back in problem B to be the moles in the original and the gas. And that is how you find the mass of it in the solid, which is 0.02433 moles of fluorine in the solid. Then, to find oxygen, you do 4.267 plus X, which is what you're trying to find, which is the grams of water, equal to 3.730 plus 0.970, and you subtract, first you add up these together, or where is it, those, which gets you 4.7, then you subtract the 4.267 from both sides, eliminated it on this side, and then you subtract that from 4.7, which gets you 0.433 grams of H2O, not hydrogen. And then you go to the stoichiometry, which is 0.443 grams of H2O times 1 mole of H2O over its molar mass, which is 18.02, times the molar ratio, which is 1 to 1, and you get 0.02460 moles of oxygen. Then you put it over the lowest amount, which is the uranium, which is at a 0.0121, and you divide them. So you're left with 1 uranium, 2 fluorine and 2 oxygen. Well, you round up here and you round up there, or round down there because they're low enough and this one's high enough. Which leaves you with UF2O2. Now, for question D, it is write a balanced formula for the reaction between UF6 and H2O. Assume that the empirical formula of the gas is also the true formula. So for this one, this is pretty easy because all you really have to do is match up the hydrogens. So you have the UF6 plus 2 H2O, which yields UF2O2 plus 4HF. And you see there's 4 hydrogen, and 4 hydrogen, and 6 fluorine, 1 uranium, and 2 oxygen. And that wraps up AP problem number 1. Thank you.